Reactive Extensions, RxJS, Advent of Code. Hello everyone, I'm your usual host, Matthew Podwysocki, aka Bluer Than Blue Falcon, aka Lambda Calrissian on the Twitter sphere. So this is day 19 of our little adventure into RxJS. So I hope that you've been following along. I've got all the other videos and the code snippets out there, catching you all up to date of where we are today. So let's kind of review where we are. So like I said, is that we started off with creating our observables, so understanding the very concepts of of what an observable is, and what an observer is, and what a subscription is. Then from there, we talked about another aspect of observables, which at least for Rx is the notion of schedulers, something to introduce some sort of virtual timing mechanism in there, so that when you're talking about asynchronous values over time, you can actually verifiably program against these things. Then we finally went into creating observables in an easy way, in that we have a bunch of factory methods that allow you to create observables from pretty much any particular data structure that you want. Then we talked about the basics of interval versus timer, and why you would use those for gaming purposes or long polling. And then observables, events to observables, obviously that's our bread and butter, because of course that we, like I said in the previous video, that our reason for being, as it were, was to make events a first-class object instead of these callbacks, which are not really compositional. So creating this observable as our first-class event was really our first and foremost goal. But then it certainly blossomed into something else. Then from there we talked about our basic composition and our basic composition model, how it changed over time from the dot operators, where you could dot together 19 operators if you wanted to, and we know that there are a lot of them. You just have to look at the RxJS documentation to kind of know how many that we have out there, and then how many there are in userland that are fairly interesting. But this changed over time as JavaScript evolved and packaging evolved, where we wanted to tree shake to only bring in the pieces that we want to bring in and get rid of all the rest. So the reason for doing the pipe was, and lettable in pipe, was to only bring in the pieces that you need, throw away the rest if you're never going to use them. Why keep dead code around on your website if you're never going to use it? Then we went to mapping and filtering. I still need to add a little bit more detail to that, like map to and so forth, and pluck, that I didn't quite add in there, but they're all basically the same thing in terms of map to versus map. So map is the idea of taking a value and projecting it to a new value and a new observable. So once again, thinking of the observable as an immutable data structure over time, that you're projecting to a new observable and not modifying the existing one. And the same goes for filtering. You're filtering out values and only taking the new values that happen to be truthy for the predicate that you give us. And we've got several other interesting operators, so let's go over to our reference here. We have map to and pluck. So map to is an easy way of just saying, for example, that a mouse down will always equal a false or a true. Just so that instead of projecting the event args or whatever it's projecting a constant value, so true or false, 1 or 2, whatever you want to project, it will project a constant value for you going forward. And that's pretty useful, like I said, if you're combining streams and you want to say true until false or what have you. Pluck is a different way of extracting values that allows you to pluck pieces from your there we are, pluck. Pluck allows you to pick out individual pieces of an object just by giving it string names. So for example, if you wanted the event, someone's name, for example, you would just give it the string name and it would pluck out the name property from that given object. Pretty simple, but I just wanted people to be aware that there are other operators I haven't explicitly called out. Then we went on to scan, because what I was leading up to in the first part was leading up to talking about Redux and various state management things that have been fairly popular in the JavaScript world now. And so we tried, what I was trying to do is give you a way that you can reason about RxJS in the very same way. So if you know how to use Redux, you get those absolutely for free in terms of Rx already has a lot of those things built in for you. So that's cool. And then, of course, start with, end with, and all of that. Start with is more particularly interesting, especially in the case of Redux. And then we talked about subjects, which are these pieces that are probably a little overused in Rx in the fact that it allows you to be both a listener and or rather a subscriber and a producer at the same time. Most of the time, you're not going to want to do that. You're just going to want a new observable, but sometimes a subject makes a lot of sense. For example, handling your state management. So going back here, there was a little bit of a correction, and thank you very much, Marcus Nielsen, for that in terms of how we did our Rx version. We have at the start with in the initial part of the pipe, then followed by our reducer, so we don't have to give our initial state twice. That was my mistake. But so thank you very much for the piece there. But like I said, is the fact that since we can easily implement these things, it's great that you can reuse your investments in RxJS as you're going along. And there are plenty of libraries out there that interoperate with Redux or take the place thereof. So you don't have to necessarily throw away any of the investments that you've made. Just continue on using what you like to use, and then we'll support you through that. So going back here, then we started talking about combining sequences. So there's zip and combine latest as ways of, and with latest from, as ways of combining multiple sequences into a single sequence. Then we also covered after that, we talked about sequences of sequences. So for example, if you're projecting and you have mouse movements or anything like that, that you can project the current mouse movement value and project it to some other observable, which then makes it an observable of observables. And then you need some sort of flattening or smushing piece there in order to make sense of that, because you don't want to have to hand smush it yourself. You can say either it goes sequentially via concat, or it goes concurrent with merge, or that you only want the latest, which was switch map. And that was what we talked about last time, which was getting only the last data. So highly suggest that you go through and dig through the code here. So the first part of what we're going to talk about today is how we're going to follow up with our auto-suggest scenario. So with the auto-suggest scenario, as you can go through pretty much any website and get hints along the way for typing ahead, for saying, okay, if you type React, you get these results. If you type reactive, you get these results. And so switch map was a way, instead of merge map, switch map was a way in that instead of getting all of the results for each and every one of them, we only want the latest one to react. The latest one, not to react, but rather the last one in line should win, and not just the first to respond wins. Because the last thing you'd want to do is give anyone stale data. And that was the difference between concat and merge, is the fact that merge can the results can happen in any order coming through that projection during the flattening of observables, so that if you type in foo, bar, and baz, the results may come out of order, and that's not always desirable. So by using switch map, that allows us to take our last query and ensure that our last query comes through. Now, what we're going to want to do on the other side of that is to tame the user input into the stream itself to make sure that that what you're giving us isn't overloading the server altogether, because I can keep sending you next, 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 and totally overload your server. And the fact that we'll keep doing all of these requests, and then switch map will be going back and trying to cancel the request best it can. But obviously, if there are promises without the abort controller or something like that, there's no deterministic way that you can tear those down. So you're just basically wasting your bandwidth at that point. So how can we tame those particular pieces? Well, there are a number of ways that we can do that. The first thing I want to talk about is getting distinct data, for example. And it's an overall topic of just making sure that the data that you're passing in is in fact distinct in some way, somehow. So we have a number of ways about doing that, either in a streaming version of just comparing the previous, or distinct for all time. So let's talk about distinct, for example. So distinct allows us to, when compared to others in this particular observable, will only give us the distinct values. So for example, if we have a subject here and we call distinct on it through our pipe, it only fires when the value happens to be distinct. So for example here, when we have given a value of next of 1, it will fire distinct item next 1, because and it will go through to the next caller. And the same thing goes for next with 2, but it won't happen for the next 2 times here when you call next of 1 and next of 2, and then it'll fire again when you say next of 3. So internally, what it's doing is it's keeping a map of what you have in the data now, of what you have, so that for comparison purposes, it can figure out what to keep and what's distinct and what's not. And if you really care about the source, and like I said, I highly suggest that you take a look at the code just for learning purposes. And if we look at distinct, we will basically have a whole set of values sitting behind the scenes, and this set is what determines what we keep and what we don't. The problem, obviously, is that if you're dealing with streaming values, this can be extraordinarily huge over time, and so it's not exactly a great thing that this could be kept around for all time. Now, luckily, what you might see out here, which is fairly interesting, is this flushes. And this flushes is the ability for us to kind of look into or rather truncate our set whenever we whenever we say, oh, by the way, on an interval of every 15 seconds or 20 seconds, clear it out. It doesn't make any more sense anymore. That would, to me, that makes a lot of sense in that it allows us to not have it this observable that is really, really huge and just gains so much weight over time that it becomes untenable. Now, we also have the ability to peek inside of your objects as well. So, for example, if you have a particular key that you care about, then what is considered unique for this particular piece. So, for example, if we had a person object, and that person object, what's distinct about it is the name, then we can project that forward in the key selector to determine whether or not this particular value is distinct or not. So it's really kind of a nice thing to have, and like I said, is the flushes that we looked at before, where we can set the interval at any particular thing that we want to, but you can have any observable or subject rather be put into here, and when it fires its next value, that's when the cache is flushed. Now that's all well and interesting, but it doesn't super apply to our example of distinct values just from the previous. So when we're talking about going through, even to the URL bar and going left or right or something like that. But if we've got a listener, for example, on key up, so every time the key up happens, this will fire and it will give us the same string time and time again. Well, the problem with that obviously is the fact that the actual text isn't changing at all, but the fact of moving the keys here did make it, that event fire. So what do we need to do in order to say, well, if it still hasn't changed from the previous, don't fire it at all? I mean, we can still do 1, 2, 1, 2, 1, 2, and those will still go through just fine. But if it's always going to be foo, 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 and I'm just doing things like that that have no real consequence to the value that we're projecting, then we want to filter that out. So to kind of give you a little example in our code here, we can say, okay, next is 1, and it says, okay, distinct item 1. If we fire 1 again, nothing happens. But when we fire 2, then it will come through and say, oh, okay, so 2 is different from 1, so I'm going to fire that again. Then I can fire 1 again, and then I can fire 2 again. But if I fire 2 after that, after 2 has already been fired, it's not going to be projected out towards us. So that gives you a little bit of an idea of like, for example, with our text box in our text change, that we will only really emit when the data is actually changed. And we also, just like above, give you an ability to kind of peek in to the object and project out a value. Here it's a little bit different. And here it's different because what we want to do is give you a way to say what's exactly equal about this. So if we get the previous value and the current value and compare those, then what's equal or not. So in the case of a person, since there's no real equality operation that we can implement in JavaScript just yet, but if we could, so instead what we give you is a custom equality piece that you can implement yourself to do that. So once again, we can just check the name on the previous and to the current. And we can also give you a way, instead of using the way of just an equality piece, there's also a way of doing it by a distinct key. And that distinct key is kind of like the pluck thing, is it just takes the key for that given property and say, okay, for the name, I will look for the distinct until changed on that particular name. So once again, kind of super handy to have. So the next part, and the part that we're going to talk about a little bit more today, is the difference is debouncing or throttling our input. And what the heck is the difference between the two anyways? Because there is a difference in why you would want to do one versus the other. So if we think about this, throttling, what exactly does throttling mean? Well, it means it enforces the maximum number of times your function can be called over a given time period. So for example, I can only call my search every 100 milliseconds or something like that. And if I call it more than that, then I'm just going to drop those things on the floor. Now, debouncing, on the other hand, is a way that you cannot call your function until a certain amount of time has passed without it being called. So, for example, if I'm a super fast typer here, and I type in foo, then I typed in foobar, and then typed in foobar baz, what exactly happens? Well, I wanted to wait for a little bit, and then wait for foobar, or wait for foobar baz to resolve, because I keep on typing really, really fast. The last thing you want to do is you want to send every keystroke to the particular user. So what does that mean code-wise? Well, let's take a look on what that actually means. So I have here prepared for us already what exactly that means. So I have two function definitions here. And one is for throttle and one is for debounce, just to kind of give you an idea of the difference between the two. So for throttle, like I said, is we have a delay of a certain number. That delay could be like 500 milliseconds, what have you. And then so in the inner function of what we're going to call with our outer function with our args, is that we're going to compare it with now and when it was last called versus the delay. And if it's still within that throttled time period, we're just going to go and return. We're not going to actually do anything. And then if it is outside of that throttle window, then we can set the last call to what it currently is, and then call the return the function of with its arguments in there. Now, debounce, like I said, is a little bit different in the fact that it turns your function asynchronous in a way. So here we have debounce with a given delay and a function. So we have this timer ID sitting out here. So if the timer ID, so by the time we call our function, if the timer ID is still alive, then clear it. Meaning, if it's still alive, clear it, cancel it. Otherwise, we're going to set the timer ID to set the timeout, call the inner function, set the timer ID to null, which means, okay, I've already called it, and then with a delay. So that's kind of the difference between the two and why they're useful. And we'll dig into some code examples at some point in terms of showing how that's useful. But let's go back to Rx and see what exactly we have here. So we have in Rx, we have a number of ways about describing debounce and throttle. So the first one we're going to look at is debounce. So the debounce is going to give us a duration selector, and so that duration selector is going to give us an inner value from our observable that we can project into a new subscribable promise, whatever it is. So it could be an observable, it could be anything like that. So what you could do is you could debounce and pass in interval if you really want to, or timer, or something that fires over in a specific period of time. Or it could be your own custom subjects. It's largely up to you in terms of what you want the debounce to be. So like I said, is you could set it to interval, you could set it to timer, you can set it to any number of things of when it actually fires. So it's giving you kind of the freedom to determine when that debounce happens, versus a more time-based approach with debounce time. So debounce time is exactly what you would think it would be, which is no different than what we had with our set timeout and clear timeout function down in our code. We have here is a due time, and instead of using the paradigm of set timeout, clear timeout, we have our introduction of our scheduler, so that we can fully test our way of whether we're debouncing or not. And that's really critical, obviously, because for testing purposes, you want something that's deterministic, repeatable, and so forth, instead of waiting for these weird timing effects, especially in the browser or in Node. So having something deterministic, especially for testing, is really, really helpful. Otherwise, we also have throttle and throttle time, and that's exactly the same kind of thing we had for the throttle function, which I showed earlier, but in Rx itself. So it emits a value from our observable and then ignores the values in this observable for that subsequent duration selector, whatever it happens to be. Once again, this is a duration selector. You can put in whatever value you happen to want, whether it's a subject or a timer or an interval. It's largely up to you. So how that's different is like I said, is we have this notion, once again, is throttle time. So if you just want to say 500 milliseconds, a second, whatever it is, pretty easy to do those things as well. And the scheduler piece here is interesting in terms of it can be any particular scheduler that you want to use. Once again, because that scheduler has that notion of what now happens to be, or the now for our virtual time. So once the now for our virtual time has been thrown in there, then it knows when it can stop or start firing values again, or when it can keep dropping them on the floor. The third piece, which is fairly interesting and a rather newer addition to Rx, is this config object right here. And this config object allows you to determine whether you have trailing and leading throttled values. So whether they happen to be on the front end or back end is largely up to you, because a lot of the times we had people asking whether it was throttle inclusive or exclusive, and there are a lot of those kinds of operations, take until, skip until, those sorts of things. Take until, exclusive, inclusive, when to basically draw the line of saying that there's no more values to be had for this particular observable stream. That's kind of cool, how you can do a lot of really interesting things of controlling the user input. And there are a lot of other things that you can also do to look at values over time, such as the time interval which tells you the interval between the values that happen to be emitted, and also timestamp, just to give you an absolute timestamp of when your particular value fired. It's good for metrics and other things as well, but I thought I'd just kind of whet your appetite as to what's the art of the possible. So once again, I want to thank you very much for your time here. Like I said, if you love what you're seeing here, please do follow along. Follow me on Twitch here, Bluer Than Blue Falcon, on Twitter at Matt Podwysocki, MattPodwysocki, and I will be posting all of this to GitHub and pushing out the videos to YouTube. So once again, thank you all, and stay tuned for the next episode. Bye-bye.